can have some reference later if somebody has not attended or somebody was not available. So for the purpose of referencing, we will have the class recorded and somebody can always access it. After the class, I will post it in the YouTube so that people can look at it. The other thing about this course is that the coursework or the quizzes, I will be giving them after each and every class. So there will not be like a cut 1 or a cut 2, but the lecture quizzes, which I will be giving at the end of each class, are the ones which we will use as the coursework at the end of the semester. So I would request that you take them seriously so that you will not be disadvantaged. The reason for giving this is because we are meeting online and maybe sometimes we may not be able to account or we may not be able to understand. Yes, Teresia, you have raised your hand. Teresia, you had raised your hand. Okay, just for the purpose, you can excuse yourself or you can raise your hand. I will be able to see it and I will be giving you a chance to at least speak. So when you're ready, Teresia, you can let me know because I didn't see you unmute your mic for you to speak. But I hope we are all together. I hope you can speak. You can use the chat section where you can type whatever you want to communicate. I will be able to see it and I can respond together. And like I had said, there will be lecture quizzes. After each lecture, there will be a quiz which is now going to help you in how to study. After each lecture also, I will be sharing the notes that we have covered and I will also share the course textbook, which we are going to use. After you have done the quiz, I will be able to get your email addresses from there and I will be able now to send you the notes and the course textbook. So I hope there we understand one another. Okay, so let us now go straight. Don't worry about the course code. It is for another class, but it is basically operating systems. So it is not anything different. It is only that in different places we use different codes. So it is only the code which is different, but the course content is the same with what you are doing. If I am not wrong, this course is supposed to be which code? It is supposed to be BCT 123 or BBIT 422. So I hope everybody who is here is attending that class. Now, I would like us to go through the course outline briefly, just to understand what we will be covering by the end of this class. So basically, we will try and understand what an operating system is. Just as an overview, that is the first thing that we will do, understanding what an operating system is. Then after understanding what an operating system is, we will move on to get an understanding of how operating systems work or how they are normally set up in the hardware in order for them to be able to. Then after that, we shall be able to look into how, now in detail, we shall be able to look at the layers of a computer system. We will also be able to look at the operating system services, the kernel, the job control language, time sharing, memory management, file sharing, paging, virtual memory. All those are different services which are normally offered by operating systems. So we will go through them to understand how operating systems work. We will also be able to understand the overview of our computer systems, like the basic elements which make up the computer system, and these basic elements, how they normally work, that is the processor, the instruction cycle, direct memory access. Then after understanding about direct memory access, we will go into process control. We will also go to threads and the relationship between threads and processes, also the microkernels and the link states of systems or different operating systems. So there will be also some practical classes there which will help us to understand what it is meant by these processes and how they normally work. So also for the purpose of this course, we will be using the Linux operating system. When we shall start to do the practicals, we will base them on the Linux operating system. So I will be able also to guide you on how to install. If you don't have the Linux operating system, you can create a virtual machine, which is always on top of the Windows operating system, or you can install Linux completely. So that is something else that we will be able to look at. Then after understanding that, we will look at the mass storage structure, the file system interface, and the file system implementation, which we shall also try to do practically. So in a nutshell, that is what we will be doing. So by the end of this course, what is it that you are required to do? You are required to identify and describe some of the common computer operating systems. So that is one of the goals. Another goal which we intend is for you to be able to list and explain the basic commands in computer operating systems. That is why we shall be using the Linux operating system. Then you should also be able to describe security considerations and how to obtain, install, and update software patches. So if you have installed an operating system, you need to be able to update it. You need to be able to secure it so that it cannot be hacked into. Then after that, by the end of the course, we also expect you to be able to describe the interrupt processing, operating system organizations, the operating system kernel, the dispatcher. You should also be able to demonstrate an understanding of memory organization and management, and you also need to understand how storage allocation is done. Then you should be able to understand the virtual memory concept, how it is normally done, also paging and segmentation, as well as address mapping. Then lastly, but not the least, you should be able to describe the different file organization systems. You should also be able to explain what is file blocking and buffering, and also the file descriptor, as well as the directory structure. So that is what will be expected out of you by the end of this course. So don't worry, I was just reading through the course outline, which I will be able to share in your emails as I will be sending the first class notes. So the notes, the course textbook, the course outline, they will come when you have done the quiz and I have been able to get your email addresses. So I hope up to there we are all together. So any more time, let us now get into when we are trying to understand the principles of an operating system. The first thing we want to understand is what an operating system is. And the reason why we want to understand what an operating system is, when we call it a program, that is the first thing we want to understand. What a program is, or what a software is, and we normally describe a program as a list of instructions, or any software will be a list of instructions that will tell the hardware what to do. So when we are talking about an operating system, we are calling it a software, and we are calling it a program. or a program that acts as an intermediary between the user of the computer and the computer hardware. So I hope that makes sense. So I do hope you understand that concept of what an operating system is. It is basically a program that will be used to be in between. So we will have the operating, they will have the computer hardware somewhere down there. In between, there is the operating system, and at the top, we have the user. So basically, that is what we mean by an operating system. It acts as an intermediary between the user and the computer hardware. It will control, that is why we are saying here, it will control the execution of application programs. Now, application programs are those programs which are in the language that we users can understand. We understand the normal English language. So these programs, be it like this PowerPoint we are using, be it Facebook, be it Google, all of them will be written or will appear in the normal English language. And they will help us as the users to interact with the computer. You can click on these programs up placed on top of the operating system. And that is why we say it acts as an intermediary. So I hope that also makes sense when we are talking about it being as an intermediary. So if I may, I would like to share that image which I am looking for, just to show how the operating system appears, but I will be sharing it in a short while. So we continue just to understand. When we are looking at the operating systems, we want to understand what they are, that one we have done, then what they do, we are going to do it, and why they are important. So they are important. Already we have explained what an operating system is, because we have said it is going to be managing the computer hardware, software resources, and it provides a common service for computer programs. So the reason why it is important, or why it is used, and you cannot avoid having an operating system in your computer or in your gadget, first of all, is because of the abstraction purpose. What do we mean by abstraction? That is hiding the details of different hardware configurations so that each application doesn't have to be tailored to each possible device that might be present on the system. So that is one thing. If I can just explain it, what we mean is this, that when you are providing abstraction, is that scenario whereby you as the user or the computer hardware doesn't have to understand what the software is doing for it to work. You as the user don't know what is happening on the background. It is the operating system which is exchanging those informations with the hardware. The hardware doesn't also understand what is happening. It is the operating system which is dealing with that. That is why we say it is abstraction. When you have something which is abstract, it gives you an interface which looks very beautiful, but whatever is happening on the background, you are not able to see it. Then another reason why it is important, it is this aspect we are calling arbitration. And when we are talking about arbitration, what exactly do we mean? The operating system will be able to work on behalf of. So if you become an arbiter, when you hear of the term arbitration. It's like somebody acting as Kofi Annan. In between, there is this group which doesn't understand this other group, and the operating system will come in between. So here we are looking at managing access to shared hardware resources, so that if it is a program which is asking to use the processor, it will go through the operating system. If it is another program which is trying to get into the storage, it will have to go through the operating system. And that is why we are talking about arbitration. It is the operating system which will be allocating access to the or to the processor. It will be providing or giving access to the storage locations. It will be able to provide access even to the active memory, or what we normally call the RAM. So all of those things are being managed by the operating system. That is why we are saying it will enable many applications to run simultaneously or at the same time without interfering with one another. So that arbitration function is the one which enables these applications, like you can open a Word document, you can open the browser, you can be able to open Facebook, and all of these are working at the same time without affecting one another. And that is what we mean by arbitration. Okay, then we look at the resources which need to be managed, because we have said through this abstraction and arbitration, it is basically managing these hardware resources. That is why we are looking at these hardware resources which are normally managed through those two functions we are calling arbitration and abstraction. So there will be the hardware which is managed, including the central processing unit, or basically the processor. Then you can find the processor being one, or you can find other machines having more than one processor. That is why we are also talking about these multiple processors which are in executing instructions in parallel. So they also need to be managed. Then we are also managing the memory. Memory is also being managed because it is organized at different levels and it is accessed at different speeds. We have the permanent storage, we have the random storage, we also have the, like we will see, we shall be having the, what do we call it? The cache memory, the registers, all of those are memory which can be accessed and they need to be managed. That is why we are talking about that. Then we also have other hardware which needs to be managed, which we call the input and output devices. That is the keyboard, the mouse, the screen, the printer, even the network interface card. All of those are hardware components attached to the CPU, and they need to be managed on how they access the processor, how they access the storage locations, and all of that, so that they don't consume a lot of memory, so that they don't interfere with one another. Then there is also power and system management. So here, it is not basically an hardware component, but the hardware requires power in order for it to work. That is why it needs to be also managed. So we manage the power supply, how power is going to the different components of the computer. We also managing the internal cooling systems, that is the fans and the other cooling components available inside the computer. So let us go into that. Abstraction is going to manage these different hardware components, or it is going to ensure these different hardware components are working properly or smoothly without interfering with one another. This is because each component has a different manufacturer, or each component comes from a different manufacturer. And these manufacturers need to design these components so that they can have the same interface within the software applications which they are using. So the hardware devices or the hardware components are they normally have what we call low-level instructions that will help them to configure themselves. So when we are calling these low-level instructions, this is what we mean. Those hardware devices, there is something we normally call self-configuration. Each device or each hardware component, if now you brought in a new USB drive and you want to use it in your computer and you have never used it before, the moment you attach it into your computer, it will first install itself, or it will be configured so that it can be read and understood by the operating system. Now, those instructions, which we are calling low-level instructions, they are usually in the language of zeros and ones. That is why they are very difficult for human beings to understand, but the operating system is able to understand them. So that will be one of the functions of the operating system. So when you see the computer telling you, please wait, installation in process, what it is basically doing, it is the operating system which is trying to register, which is trying to configure and set up that hardware component so that it can be able to be used in the computer. And when you talk about being used in the computer, it's basically trying to exchange information or trying to communicate with the computer software, which is available in the computer, and the computer processor. So these hardware component or hardware devices, they also have different capabilities, features, and details. So since they are unique by themselves, they need to be configured so that they are uniform within that available operating system. So if there wasn't a common interface in these hardware devices, what would happen is that if it is an HP computer, it would only use HP components. But nowadays we can buy an HP computer and you can plug in a Lenovo keyboard, you can plug in maybe a Sun mouse, and it is able to work. These USB devices, we don't know where they are coming from, different manufacturers, but they are working all together the same because of that function of abstraction. So before the 1990s, we are saying that different hardware components had to be configured manually, and it was very difficult for some of them to be used. But now with advance in technology, we just do what we call plug and play, and it has worked. Then we come to arbitration. Arbitration, like we had said, it is that function of trying to work on behalf or working in between, receiving instructions from one level and translating them, then transferring them to the next level where they are required. So what we are saying is here is that computers used to run one application at a time. But nowadays, these hardware are able to run multiple applications simultaneously. So it is up to the operating system to ensure that these applications are able to access resources efficiently and effectively through these activities. One is dividing each CPU time among different programs. So even if you have 10 applications open in your computer, each application will have a specific time when it is accessing the CPU. So that is work of the operating system. Each program also needs to get access to the random access memory. Why? Because the RAM is where each application is running. So each application needs to be allocated a space where it can run. That is why we are always increasing this RAM space from 512. Now we are talking about 8 GB RAM, 16 GB RAM, which is a lot of RAM, so that it can allow many programs to run as much as they are heavy. Also, the input output devices, they also need to be allocated, as well as the disk storage needs to be allocated, and all of that is being done by the operating system. So that is another function which the operating system is doing. Then it is the work of the operating system to enforce system security and policies which are going to ensure that each application is working in isolation. That is why we are talking about isolating applications so that it can work on its own. If applications interfere with one another, then computers would be crashing every now and then. But because of ensuring there are security policies, then each application works independently. So, which one do we work with? Or when we are looking at these activities, how can we tell whether it is an abstraction or an arbitration which is taking place? So let me ask somebody who is among us. Boniface Otieno, when we are talking about switching between applications, are we talking of an abstraction or an arbitration function? Boniface. Cyrus, are we together there?
Yeah, we are together. Yes.
Oh, yes, yes. Now tell me, in that
Yes.
slide, we are looking at different activities which take place in a computer. When we are
Yes.
switching between applications, is that an abstraction or an arbitration?
I think it's a abstraction.
Why?
We are hiding one application's data from the other.
Eh?
We are hiding one application's data from the other.
Or we are hiding one
Yeah.
application from the other? That is
Yeah.
correct. Let me ask the other person, another person, who is that? Daniel Guto. Separating memory allocated to different applications. What is it?
Arbitration.
Eh?
Arbitration. Separating of memory allocation to different applications.
Eh? It is arbitration.
Yeah.
Why? Why do you think it is arbitration?
Because
Uh-huh.
the application need to work independently without interfering with the other.
So would that be an arbitration really? Just to confirm. Because we have said arbitration is what? Is where the operating system is working on behalf of. Anybody else who can give us an answer? This is just to help us to understand or to think through and be able to know the difference between arbitration and abstraction. Joel Makumi,
Yes.
what do
So
you think?
I think it's an abstraction. I think it's an abstraction
And why? Yes, why?
because we are switching from one application to another, meaning one
No,
meaning
we
we
are
are
in number
focusing.
two. We are in the second. We are in the second point.
Which point?
It is the second point we are looking at. Separating memory allocated to different applications. Like you have Word, Excel, maybe Facebook, you have them open, and you want to separate
Yes.
memory where they have been allocated. So what exactly do we call that? Is abstraction. I agree, but then why?
Because each and every application works on its own, and I can't get the good
Yes.
reason. Yes.
No, you are already on the right path. Each application
Yeah.
will be behaving like, you know, it has its own space. It will be behaving
Yeah.
like it is the only application running in the computer. So that is why we call
Yes.
it abstraction, because
Yes.
the memory you have been allocated, it is yours and you're good to go with it. Good. Let me go to the third one, enabling video conferencing software to use camera devices. This one I want to ask Regina Waidera. The third one, when we are talking of enabling video conferencing software to use different camera devices. Is it an abstraction or arbitration? Teresia? Regina? Mogi? Are we together, guys? Yes?
It's raining heavily over here. I don't know if you can hear me well.
Yes, I can hear you. You are audible. Kwani umezima? We could hear you properly.
I'd say I came in late, but I'd say that I can say that's an arbitration
Why?
because this is it's switching between. Let someone help me with that. I can try the next one maybe.
Okay, no problem. Regina, are we together? And Teresia and Wambua Mwaka? Or anybody who has an idea, when we are talking about video conferencing,
I think it's an arbitration
an arbitration, why?
because the video conferencing you one camera is viewed by other members, making a platform or making it a platform, then an arbitration.
Okay, so the correct answer should be abstraction. And let me give you an idea. When we are talking about, you see, it is hardware. So these cameras are hardware devices. And these hardware devices are being managed by the video conferencing software. So the video conferencing software will be on top of the operating system. And it is the work of the operating system to be able to allocate these cameras some space in the video conferencing software. So it is similar to what we have talked about in the second point, whereby we are talking about separating the memory allocated to different applications. So here, it is just the video conferencing software, which is going to be allocated different camera devices, just like you can see them on a screen. So it is the operating system which is enabling that. So anywhere there is going to be a the aspect of the hardware being allocated, it becomes an abstraction. That is what it basically means. So I hope there we get one another.
Yes, get.
Yes.
I get it now.
So when we come to, yes, so yeah. So when we are talking about now accessing two different hard disks, what would that be? Anybody can answer.
Can I say
What
it's
was
an
the question?
abstraction?
Yes. So why do we say it is an abstraction?
I can say it's an abstraction because when accessing one hard disk, when accessing one hard disk,
Yeah.
it will hide data from the other hard disk so that you will be able to only access the single data from one hard disk before you access the other data from the other hard disk.
Correct. So that is what it means. Then we go on to sending and receiving messages on a network. What can we say about sending and receiving messages on a network? What would that be?
An abstraction.
An abstraction. Why?
Because when one side the message is is hidden, then the other one sees the message as open, as encrypted. The one who sent the message is hidden through the network. The one who sent the message and the one that received the
Okay.
message, they see it's
Oh,
hidden. That yeah.
okay. But look, compare that with the first point that we had started with, where we were talking about switching between applications. That is an arbitration. Sindio, that is what we said. So the same will apply to sending and receiving messages, because these are just messages from different applications. Just imagine like you're sending an email on Gmail, but these emails are not going to interfere with one another. Like when you're sending a message on Facebook, it will go to the person it is supposed to go to. Only that. So these are different applications again. Gmail, Facebook, WhatsApp, they are all applications which are working or are being managed by the operating system so that they do not interfere with one another. Just like we could have the same with applications like Word, Excel working on the same machine. So it becomes an abstraction function. So does it make sense?
Yes.
Okay, then we
Yeah,
are
sure.
coming down to supporting both Intel and AMD. Yes, we are coming to supporting both Intel and AMD processors. What would that be? Is it an abstraction or an arbitration? So since here we are talking about processors, which are hardware components, then it will be an abstraction. So I'm just answering for you. That will be an abstraction function whereby these hardware components, they can work together in one machine, but they are coming from different manufacturers because their configurations are managed by the operating system. So they are going to work together. So basically, these are trying to show us that when it comes to managing hardware, that will basically be an abstraction function. When it comes to managing software so that it doesn't interfere with one another, that becomes an abstraction function.
Excuse me, sir. I want to
So
ask,
I hope there somebody has
could you,
learned something.
excuse me,
Yes,
could you give us more examples on arbitration? Because I see most of the examples are
yes.
on abstraction, please.
Okay, arbitration is like on the second point where we are talking about separating memory. Sorry, it is on the first point where we are talking about switching between applications, and on the point below where we are talking about sending and receiving messages on a network. So that becomes an abstraction or an arbitration function. Then the arbitration could also include whereby you are having the same hardware which is shared by multiple applications. So that hardware could be like the memory or the RAM. And this RAM is being shared by multiple applications. And these multiple applications do not interfere with one another, then it becomes an arbitration function. Also, an arbitration function could come whereby you are dividing the CPU into times so that each time there is a different application which is coming in. And that application is taking over the CPU as if it is the only application available in the computer. So I don't know if I have made sense.
Yes, yes, yes. Thank you. Thank you.
Repeat.
Okay. Okay, what I was saying, let me repeat. What I have said is that you could have an arbitration function whereby, just apart from protecting the applications from interfering with one another, like we had in these two examples, you could have a case whereby it is the memory, the RAM, which we normally use. And this RAM is being divided into or is being allocated to several applications. So that aspect of allocating several applications to the same random access memory, it becomes an arbitration function. Again, you could come across a scenario whereby the operating system is also trying to divide the CPU time. The CPU is a hardware, but it is going to be divided into time allocations so that at a specific time, it is an application which is in that CPU. And then after that time, another application comes in. And after that specified time, another application comes in, such that it is only one application at a time. So when you divide that CPU into different time slots, then it also becomes an arbitration function. Hapo make sense? Somebody had asked me to repeat it. Has it made sense?
Yes, yes.
Okay, thank you. Let us move on now. So those are the two basic functions we look at. Yes?
Though your second point seems so challenging, I don't know why.
It seems challenging.
Yes, yes.
Okay, why? I have said when it is the aspect of the software. Yes, Cyrus, I can see you have raised your hand. Had you raised your hand, Cyrus? Yes, your hand is up.
Examples.
You want examples?
Yeah, of abstraction.
Okay, like what I okay, when we are talking about abstraction, it's basically about hardware. Sawa sawa. Like we had given the example of this hardware whereby we have a processor from AMD. AMD is a manufacturer. Intel is also a manufacturer. And these two CPUs or these two processors are put in one computer and they can work together. So when it comes to managing those hardwares, then that becomes an abstraction because each one of those hardwares has their own configurations, but they have to be interfaced with the computer, and that is through the operating system. Hapo nimemake good example. Hiyo ni ya abstraction. So abstraction comes when we are dealing with hardware, basically. But I went on and said arbitration can happen in hardware in this way. Like for example, you have this processor, and this processor, you want it to work by what we call time scheduling, whereby maybe in the first 2 microseconds, it is this application which is in the processor. Then after 2 microseconds, it is another application which is coming into the processor. So when you divide it into different times so that each application accesses that hardware at its own specified time, then it becomes an arbitration function. Abstraction is coming whereby we have these two different hardware components which need to work together in the same computer. Like those two processors we are talking, supporting both Intel and AMD processor, or separating the memory allocated to a different applications. So I don't know if I am making sense.
Yes.
Okay, no problem. I will share the notes and also share some more examples on this one so that you can get, because those are the two basic functions of an operating system. Like that is why we say an operating system is important, because it will be managing those two functions. There are other small functions like memory allocations, so we will deal with them, but they are all under either arbitration or abstraction. But we will get there. So when I will be sending the notes, I will also share that. So let us proceed to the layers of the operating system or the layers of the system. So a computer normally will have hardware at the bottom, and that hardware is where the operating system will sit on. And then we will have libraries and utilities, and then the application programs, which we normally interact with. So at the top here is the user, and the user will interact with the application program like Word or Excel or this PowerPoint by clicking these icons like file. When you click here, it will take you somewhere. When you try to edit your document, it will be able to do that. So you as the user are interacting with the application program. Also with the libraries and utilities. Libraries and utilities are normally what we call software development programs, like Java, Visual Basic, C, C++. You will find them here. We also interact with them. And we have utilities. Utility programs are those programs which help us to use our computers in a good way, like the antivirus programs or the firewalls. They are normally found on this layer. But the applications and libraries and utilities are normally translated by the operating system, because we as the users will interact with them using the normal English language. Whatever I'm clicking, whatever I'm trying to type is in the normal English language. But the hardware down here, which is supposed to execute what we are doing, doesn't understand the high-level language or the English language. What it understands is the hardware language, or what we are calling the language of zeros and ones, or the bit language. So it is the work of the operating system. That is why we are calling it the middleman or the interface. So its work as the middleman or the interface is to translate these instructions, which are coming from up here, and translate them to the language which the hardware can understand, the language of zeros and ones. Then the hardware will execute what we need it to execute. After it has executed, it will give the response back to the operating system. The operating system will translate it back to the normal English language or to the function that we needed executed. So I hope that diagram makes sense. So let us look at the kernel and the user space. The kernel is normally the central part of the operating system, or the core part of the operating system, which the operating system will not function without. So the operating system, we can remove the things to do with graphics, we can remove the things to do with icons, we can remove the things to do with mouse, and remain with just the keyboard, just like it is done in Linux. You can remain with the keyboard and the CPU, and you start executing your functions. That is why sometimes you will hear that Linux is a kernel. It is a kernel operating system. It is not like the bloated operating system where we have the graphic libraries, we have the icon libraries. All of those things are just add-ons to help the user have a good experience, but they can be removed and we remain with the kernel, and we can still perform the functions that we needed to have performed. So the kernel is the core of the operating system, which has the minimum piece of the software that is needed to still act as an intermediary between the hardware and other applications in the computer. So I hope you understand what we mean by a kernel. So the kernel will be this part of the operating system which will interact with the user, but these other capabilities which are provided in the operating system are just for creating or enhancing the experience which the user requires. Like, not everybody is a programmer for them to understand how instructions are given to the operating system without the use of icons and typing in the interface, the graphic interface, which we are used to. That is why we have added these other components. So that is what we mean by the kernel. So this other part is what we normally call the user space, and the core of the operating system is what we normally call the kernel. So when we are talking about abstraction, again, we are talking about now communication with the hardware. Like I had said, every activity which you will come across trying to ensure that hardware is properly configured to the computer, different hardwares from different manufacturers are able to communicate with one another. That is like having the keyboard and the mouse and the processor from different manufacturers. But once you connect them, the operating system is able to configure them for them to work together. Then that becomes what we call abstraction. And that is why we are talking about the operating system being able to provide a common mechanism for allowing applications to access the hardware. So that is what is meant by abstraction. So these applications will make requests from the operating system, and they will need to go through the operating system to get to the hardware where now they can be executed. And that is what we mean by abstraction. The operating system is also able to alert applications of any changes, or what we call interrupts. This is something we will look at as we continue from here. And when we talk about interrupt handling, is when you have pressed a key on the keyboard and it is trying to give a specific instruction to the processor. Like when you press F5, maybe it's to refresh your machine, or you're trying to press F4 to try and project something using the projector, all of those, and different keyboard combinations which you are performing, and they are able, like when you press Control Alt and Delete at the same time, it is supposed to invoke the task manager. So all of those are like interrupts which are being sent to the processor for it to act in a certain way. When you click somewhere, that is an interrupt or a signal that you have sent to the processor for it to react in a certain way. So that is normally what is being done. Then they are also saying that the operating system can manage and terminate applications whereby these applications are sending signals to those applications, or applications are sending signals to other applications in order for them to terminate. Like we have said, the task manager. When I select Control Alt Delete, and then the task manager comes up, and I am able to see the list of programs which are running, and then I select one program and I say end it. That is sending, this task manager application is sending a signal to the other application to be stopped. And that is what we are talking about here. So when we are looking at these operating systems, we have the Microsoft Windows, or those operating systems which have a graphical user interface, or what we normally call the GUI, the graphical user interface. These ones always have like icons and graphics and pictures which enable users to understand what is happening, or they can click on them to execute different commands. But then we have the Unix-based operating systems like the Linux, which has the Android, Symbian, BlackBerry, Ubuntu, Fedora. All of these are now what we call the command-based or command line interface, the CLI. Those ones normally depend on commands for them to work. So if you don't know them, you are not able to interact. So they are normally in those two categories. We have one category which has the graphical user interface, and another category which has the command line interface. Up to the DOS, MS-DOS, like we know it, it always has the command line interface. So those are the two categories of operating system. Anything in between will always lie in one of the categories. Then in these operating systems, they are there so that they can provide convenience, so that they can offer efficiency, and they give the ability to evolve, meaning that you can update, you can bring in new applications, you can bring in new functionalities. So operating systems are there to provide these three things: convenience, efficiency, and ability to evolve. And they will be able to do that through the following services. One is program development, like we have seen in the utilities and all of that, libraries. You are able now to develop other programs to help you to do things. And that brings about the ability to involve program execution. That is, you can install programs which are able to execute or run and perform functions on your behalf. That is providing convenience and efficiency. Also, providing access to input-output devices, and that also brings about convenience and efficiency. File system access, and error detection and response. Error detection is very important. Whenever there is any challenge, it is the operating system which will be able to notice it, give you a notification, or once it has detected, it will respond either by correcting that error, that is self-repair or self-healing, or it will notify you as the user so that you can work on that error. So the role of the operating system, like we have said, is one, when you are looking at from different viewpoints. One is to provide convenience, ease of use, and good performance. That is why we normally go to buy these new computers which have these operating systems, which have these functionalities, is because of that aspect of convenience, ease of use, and good performance. And by that time, we do not care about resource utilization. So somebody will pay for whatever it is for them to get those attributes. But There are also shared computers such as the mainframes and mini computers, which ensures that everybody needs to be happy, everybody needs to have their resources allocated to them as users. And then users will always dedicate or will have dedicated workstations or interfaces which will enable them to get the resources that they need. And we also have others like handheld computers, which are resource poor, but they are optimized for usability and battery life. We know them like the uh, palm tops, the tablets, all of those are normally utilized for this function. And then we also have computers which have little or no interface, and they are normally embedded. So they have specific functions and they are embedded on other systems for them to work, like the ones we normally put in devices or automobiles. Like when we are talking about embedded devices, think of these wearables which we wear, so that they are connected to our mobile phones, but they are worn into our bodies so that they can always support the function of these mobile gadgets we are using. Think of these navigation devices we normally put in our cars so that they can be able to tell us the direction to a specific space. Those are the examples we are talking about there. Then the computer now would be that set of resources which would be like copying data, storing or processing, which will be able to help the user to accomplish a specific task. And at that moment, the operating system becomes responsible for managing these resources. Could, would it be copying data, storing or processing that data? It is the operating system which manages those resources. So when we look at the computer as a big picture, then we will know that the computer will be divided into the component called the hardware, which is the CPU, memory, and input-output devices. Then we have the operating system, which we have said is an in-between, or the one we have called the arbiter or the abstractor. And then we have application programs, which are for specific functions like word processors, compilers, web browsers, video games, all of those. And then the last component will always be users. Would it be other people or other machines or other computers, like we have said in the case of cars? Then those are the users who are using these system components. And then lastly, this is how the abstract view of the computer components will look like. So the hardware will be here at the bottom, the operating system will be here. Then these are like the system and application programs. You could have a compiler that could be for Java or for C++, an assembler for a certain application, a text editor, which now you are using to interact with, and the user who is connected to a database system somewhere. So all of these are users of the computer system or the components which you will find in a computer system organized in an abstract view. And so, gentlemen and ladies, that is the basic introduction of how operating systems are like in a computer system. So, thank you for your time and thank you for waiting.